Welcome to our competency-based questions for class 10th physics designed to enhance your conceptual learning. Question 11. Read the information given below and answer the 5 questions that follow. Suresh bought a packet of 100 LEDs to make his own decorative lights for his house. The packet containing the LEDs had the following specifications printed on the label: LED 2835, 0.2 watt, 30 lumens, 3 volt. To understand how he should connect the LEDs, Suresh referred to the following circuit diagram shown on a website. Now this is the information that is given to us. 2835 is the code for the LED that is decided by the manufacturer. 0.28 power. The power rating of the LED is 0.2. 30 lumens is the ability of the LED to glow, that this much will be the brightness the LED will be given us on glowing, and 3 volt is the potential difference across it. So this is the circuit diagram that Suresh has referred. Now we can see that the ending of one LED is connected to the starting of another one. So it is something like this, that one LED, then another one, and this process goes on. And also after 8th, we have connected 16th LED in series, and then this is in series to the 16th LED. So we can say that all the LEDs, they are connected in series. So from the given options, all in series, all in parallel, 8 LEDs in series and then 2 in parallel, and 8 LEDs in parallel and then 2 in series, we can see that all are in series. So option 1 is correct. Let's take question number 2. If the LED marked LED2 in the diagram stops working, which other LEDs will also stop working? So this LED, it has stopped working. Now what has happened? This is the case that there is a break in the circuit because the LED has stopped working. So the current cannot flow through the circuit. And what will happen? That after it, when the circuit is not completed, there will not be a glow in each of these LEDs because they all are connected in series. And we know that when the components are connected in series, and if one component stops working, the other components also stop working. So the answer for question number 2, that if the LED2 in the circuit stops working, then all the other LEDs in the circuit will also stop working. So option 3 is correct. Question 3. Suresh decides to connect all the LEDs in his decorative light in a series combination. How many LEDs will he need to connect if the lights are to connected to a 240 volt mains? So we can draw the circuit like this, that this is LED 1, this is LED 2, and so on up to n number of LEDs. Nth LED. And they all are connected to 240 volt main supply. Now we know this thing that in the specifications given, 3 volt is the voltage across the LED. So for first LED, we are having 3 volt. And this 240, it is getting divided into n numbers, so that each of the LED will have 3 volt across it. So what I can write is 3 times n, that is equal to 240. Because this 240, it is getting divided into n number of LEDs. So n will be equal to 240 divided by 3, that is equal to 80. So the number of LEDs, they must be connected in series so that 240 volt main supply can be connected across it. It is 80. So when 80 LEDs are connected, then this complete 240 volt will be utilized. So option 2 is correct. Let's take question 4. What will happen if Suresh connects 100 LEDs all in a parallel combination? So what we are doing now, we are connecting the LEDs in parallel combination up to 100, and they all are connected to a 240-volt supply. Now, each of these LEDs will be having a 240-volt across them because in parallel, the potential difference is same. But the maximum voltage that they can withstand is 3 volt only. That is given in the specification. So if the LEDs are connected in parallel, then each of the LEDs will have a potential difference of 240 volt and therefore they get damage. So option 2 is the correct answer. Let's take question 5. How much current is each LED expected to draw when used according to the ratings given in the label? So in the label, power rating is given to us as P equal to 0.2 watt and potential difference rating is 3 volt. So P is equal to 0.2 watt and V it is equal to 3 volt. We know that P is equal to VI and from this I can write I is equal to P upon V. So that is equal to 0.2 divided by 3. So we can write it as 2 multiplied by 10 to the power minus 1 divided by 3. And 2 upon 3 it is 0.67 multiplied by 10 to the power minus 1. So that will be equal to 0.067 ampere. So this is the amount of current the LED will draw when it is connected according to the ratings given in the label. And from the given options, option 1 is the correct answer. Thank you. Keep learning, keep practicing, keep excelling.